Okay. Yeah, are you done with the calculation? Sandra?
I found the mean for other one, the first data.
For the length. Okay, what did you get for the mean? Yeah, so what do we have for the mean for length?
2.56. 2.56.
Please come again.
2.56.
For length, mean.
Yes, 2.56.
2.56. And the standard deviation?
I've not done that one. Including the mean I've done for both.
Okay, so mean for mass.
12.6.
Please come again.
12.6.
12 point. Okay. Sandra, did you say 12 point something?
2.
0.2. Okay. Now I hear you. Yes. Okay. So those who have found the standard deviation, can we have your answers? Clifford and Charles. Yeah, any response on the standard deviation?
So can you give the formula for the standard deviation again?
You want the formula?
Yes, for finding the standard deviation again.
Is the square root of summation x minus mu squared over n. Okay, we are keeping too long in calculating the standard deviation. Maybe I need to give you more time to sit back and practice, because it shouldn't take this long to find the standard deviation. So try and practice more on the standard deviation. Okay, good. And once you've obtained the standard deviation, all you need to do to find a CV, that's a coefficient of variation, is to divide the standard deviation with the mean, and you multiply by 100%. Okay. Then you do same for the data here. So you have for the coefficient of variation, you have to find the standard deviation for the mass too. Then you find the coefficient of variation over the mean times 100%. I would have been pleased if you had solved the standard deviation for me, but it appears other colleagues are not contributing. Okay, so you find the coefficient of variation for length, find the coefficient of variation for mass, and the one with the bigger coefficient of variation has more variation relative to its mean than the other data. Okay, that is how you interpret the results. Okay, yeah, so that is for the coefficient of variation as well. Now let's move on to, so now we've looked at the range, we've looked at the interquartile range, we've looked at the standard deviation and the variance, we've looked at the coefficient of variation. We as well want to revisit or to look at what we call as skewness. Okay, we want to connect the previous topic and today's topic in describing the distribution of the data. Okay, in data description or in describing the shape of the data distribution, one relevant measure to talk about is the measure of asymmetry. Okay, the measure of asymmetry, which talks about whether the curve is skewed or it is symmetric. Okay, and one statistic or one quantity which is used to describe the distribution of the data is the measure of skewness. The measure of skewness can be estimated using the Pearson's coefficient of skewness, first coefficient of skewness, which is defined as the mean minus the mode of the data over the standard deviation. And then the Pearson's second coefficient of skewness is defined as 3 times of the mean minus the median over the standard deviation. Okay, so this we use in the case when we don't have the mode of the data, or when we are not given the mode of the data. Okay, very well. So let's see how to calculate this as well. So this time you have to be quick with the calculation of the standard deviation. Okay, you have to be a bit quick with it, and please get your calculators with you. Don't sit there idle and just waste the time. Okay, good. So let's take an example and then try to find the Pearson's coefficient of skewness for the data. Okay, so we're taking this data here. We attempted this data earlier. Okay, I'm going to add, okay, fine. So let's try to do this together in order to find a mean. I don't want us, the standard deviation, I don't want us to delay much. So 4.8 minus the mean, which is 4.994, okay, 9429. What do we get? That should give us what? Negative what? Negative. Hello, class.
Yeah, sir.
Yes.
Negative 0.1421.
1429. 21. Okay.
Yes, please.
Okay. Then the next one, 5.4 minus 4.9.
It's 29.
29.
Yeah.
Okay. The next one, 5.4 minus the mean. What do we get?
Zero point 4571.
0.4571. Good. Then the next one,
Negative 1. .0429.
one,
The next one.
0.2429. Negative 0.2429.
Yeah.
okay. Next one,
1.4571.
1.4571. And then the last.
One 1.1571.
571. Okay. So next we are going to square. Okay. So when we square the first one here, which is negative 1.4429. When you square, what do you have?
Negative 0 point.
When you square negative, it's positive.
020.
So 1.4429 squared gives you what?
Okay, the first.
0.0002.
That would be for the second one, not so.
Yes.
0.002.
0.002.
Okay. Then what of the first one? 1.4429 squared. What do you have?
No, sir.
Yes.
Sir, hello.
Yes, I'm listening.
The first one is rather 0.000002.
Are you sure about that? Check it again. We are saying squared, not square root. Oh, squared should be 1.4429 times 1.44. I even have the square here. 4429. Should
But
give
it's
us.
not negative.
No, it's not negative. Okay. Now,
Because I'm seeing negative there.
let me show you how to do it. Okay. So
2.0.
I'm taking you. I think that is where your problem is coming from. So, do you see my calculator?
Yes.
So in calculating it, this is what you do. Let me clear the screen. So this will be what? First, you have to put into bracket, okay? But because I don't have brackets here, you see, because you don't have brackets here, we know that the square of a negative will be positive, okay? So it's just 1.4429 squared, okay? When you square it, you get what? 2.08 0819604. Okay, so let's keep that. So that's how you do the calculation. Okay, good. So let me go. I'm going back to my screen. You do the calculation now for me. Okay. So this gives us 2.08196. Okay. And the next one. And next one is when you do the calculation, what do you got?
Oi. Okay. So should we give it the values of the x minus mu?
Yeah, I did the square of the values. I want us to calculate at least the variance together, okay? Because so far you've not done a calculation for me, okay? But if it's going to take long, then maybe we should take it as an assignment. I wanted us to do it together. So if it's going to delay, then we have no choice than to take it as an assignment. So this is what we will do. After you found the standard deviation, okay, we have the mean. So after you found the standard deviation, the next question is you have to ask yourself whether you have the mode. If you don't have the mode, then you make use of the median, okay? So let's go to the data. For that particular data, okay, we do not have mode for the data. There is no unique mode there, okay? So what you're going to do is to find the median, okay? Median, you remember how to do it. You arrange the data in ascending order. Then you find what? The median position using n+1/2. Okay, then you find the median, okay? So after you found the median for the data, then you come and make use of the Pearson second coefficient of what? Skewness, okay? You make use of the second coefficient of skewness here, okay? Because in that data, we do not have the mode. So once you've estimated that, you will get a value. And the value of the skewness will always lie between -1 and +1, okay? The value you estimate will lie between -1 to +1 inclusive. Okay, now this is how you interpret it. If the value of the skewness, okay, is less than 0.5, that's -0.5 to 0.5. In other words, if you have a value like -0.2, okay, -0.2 is greater than -0.5, but less than 0.5. So the skewness lies within this interval, okay? If it lies within this interval, then we say that the shape of the data, the distribution of the data is approximately symmetric or approximately normal. So when we plot the distribution, it will look approximately what? Normal, okay? But if the value exceeds these values, assuming we have -0.6, -0.6 makes it skewed, negatively skewed. And then 0.6 above will also make it what? Positively skewed, okay? Will make it positively skewed. Now the question is, what do we mean by the negative skew and the positive skewness, okay? Good. Now, when you look at the formula carefully, you realize that if in this formula here, because the mean is the first factor, okay, and the median or the mode is the second quantity, if the mode is bigger than, if the mode, okay, is greater than the mean, then we are going to have a negative skewness, okay? If the mode is greater than the mean, we'll have negative skewness. The same way, if the median is greater than the mean, we'll have what? Negative skewness. Otherwise, or vice versa, it will be a positive skew, okay? So let's look at the shape of the distribution which we have seen before, but this time we want to analyze it carefully. So like we said, in the case of where you have your mode, okay, usually your data will start from for the sake of this lecture, let me put this as the least value 0, okay? And then the measures of central tendency, this is the mean. We have the mean here. Okay, the mean is X bar. The median is the middle value here. And then we have the modal value. It's always the highest occurring frequency. So in the case where the mode, like we said, the mode is bigger than the mean, the formula says mean minus mode. Okay, mean minus mode over standard deviation, over the standard deviation, ST. Okay, so if your mode exceeds the mean, then we'll get a negative value. Okay, if the mode exceeds the mean. And clearly here we can see that the mode per the scale on the x-axis, the mode is greater than what? The mode is greater than the mean. Okay, so a left skewed data is also referred to as a negatively skewed distribution. Okay, left skewed means, the word skewness means shunning. Skew means to shun. So it appears the data is shunning the left side in favor of the right. So a left skewed data is also what? Negatively skewed distribution. Okay, the same way when we go to a positive skewed distribution, this is how it will look like. This time, for the same data, like we said, it always starts from 0 here, right? So for the same data, this time around, this is your mean. Your mean is the maximum value on the x-axis. This is the mean. And then this is the mode. So the mode is smaller than the mean. So we have X bar is greater than what? The mode of the distribution. So when you find this quantity here, it's going to be positive. Okay, so we say that it's a positively skewed distribution, or a right skewed what? Distribution. Okay, so you take note of these relationships. Okay, very good. So what we are saying in summary is the measures of variation together with the measures of central tendency help us to describe the shape of the distribution. And one such parameter we can estimate from these two quantities, from these quantities, is the measure of skewness, okay? Others will be the measure of kurtosis. But today we've looked at how to estimate the skewness of the data and how to interpret the skewness of the data. And my class will not be complete until I have you at least solve one example for me. I want to make sure that you know how to calculate the standard deviation before I leave class. So I still insist we solve one example online. Because a lot of you, just after the class, will even forget to go back and solve it. So it will be advisable we solve the standard deviation. We are able to find the standard deviation and the mean. So I'm still going to give you one simple data. I want to be very sure that you understand this thing I've taught before we leave class. So let me give you a simple data. So I want you to first find the mean. I want you to find the mean. Okay, the mean. And then 2, the standard deviation. Okay, the standard deviation. And then 3, you have to find the Pearson's coefficient of skewness. Okay, we'll take the second coefficient of skewness. Okay, for the given data. So let me give the data 3, 4, 4. Let's have 5. This is very simple. Okay, so very, very simple example. And I'm giving you the formulas. Please do it for me and be quick about it. So summation x minus x mu square so please be quick about it. So the standard deviation, I'm putting the formula here. That's the square root of summation x minus mu square over what? Over n, okay? And then the Pearson's coefficient, second coefficient of skewness is 3 times of the mean minus the median okay, over the standard deviation, So do the calculation for me. I'm waiting for your solution this time. Are you almost done?
Partially.
Okay. I'm waiting. I'm waiting patiently.
It's